Hello, everyone. Welcome to Simon's Tutoring. Today, we will learn about limits. The limit is the fundamental building block for calculus. To understand calculus, you should be familiar with the concept of a limit. In the last lesson, I explained that English describes something while mathematical language defines it. We can translate the term limit as approaching. Therefore, a limit in math is a variable approaching a given value. As shown in the diagram, there are two approaches, horizontal and vertical. To be familiar with limits, you need to know how the symbol of a limit can translate to English. In this symbol, LIM x arrow A describes that x approaches A, and the symbol LIM fx expresses that fx approaches somewhere. Therefore, the symbol for this can be interpreted as follows. If the x-coordinate or input variable approaches a fixed value a, then the y-coordinate or output of the function fx approaches fa. This slide shows how the English phrase x approaches 1, the fx approaches 2 in the function for fx is 2x can be translated into mathematical language and visualized in a graph. This slide shows the limit of a different function fx is x squared minus x. We can see that there are two directions to approach 1 on the x-axis from the left-hand side and the right-hand side. There are two different directions for approaching at 2 from the bottom and the top on the y-axis. This is called one-sided limits. The table on the left shows the fx, which is x squared minus x. In this function, when the x values approach 2 as the x-coordinate approaches 2 from the left. The table on the right shows how the fx values approach 2 as the x-coordinate approaches 2 from the right in the function fx. However, some functions do not have a limit. The graph on the right shows a piecewise function. Piecewise functions represent a function as two or more pieces because a single function can't capture the situation we want. In this function, the x value approaches 2 from the left, and the output is found on the line on the left in the graph. The y-coordinate approaches 2. However, when the x value approaches 2 from the right, we need to follow the graph on the right to find the y value. Then it approaches 3. In the graph, we indicate that the limit values that approach from the 2 to the left and from the 2 to the right have different results. In this situation, we define the limit as not existing because the left-hand and right-hand limits differ, or the limit does not exist because the one-sided limits differ. As you have seen many times, some types of functions have essentially a limit that does not exist, such as the rational function. The rational function x over x minus 1 is given. The table below shows the x values approach from the left side, such as 0.9, 0.99, and 0.999, etc. The result of fx is getting bigger with a negative value as negative infinity. The x values approach from the right side, such as 1.1, 1.01, and 1.001, etc. The result of fx is approaching larger as positive infinity. The long phrase I mentioned can be expressed more concisely in mathematical language as shown in the symbol in the table below. The limit as x approaches 1 from the left is fx approaching negative infinity, or the limit as x approaches 1 from the right is fx approaching positive infinity. This situation where x approaches 1 from the left or right and the fx value approaches negative or positive infinity is called a vertical asymptote. Most rational functions also have a horizontal asymptote. The table on the left shows that the value of x is getting bigger and bigger as the fx approaches 1.1 to 1. The table on the right describes the x increase negatively, a big number. The fx approaches 1 from the 0.9. Finally, the x value increases to a very large negative or positive number, and the result of fx approaches 1. This is called the horizontal asymptote of the function, which is 1. This next slide summarizes the rational function explained previously. This rational function has a vertical asymptote at x equal to 1 shown by the red vertical line. The horizontal asymptote can be expressed as the blue line, and the equation of the horizontal asymptote is y equal to 1. Let's solve the following examples to clearly understand the concept of limits. Before solving these examples, I strongly recommend translating the mathematical symbols into English rather than relying on intuition or memorization. How can we translate question number 1? First, we can read the x value approaches -4 from the left side. Look at the graph above. The red oscillating graph is located at -4 from the left side, so we can use this graph to find the fx value of the limit when x approaches from the left. The fx is going to around 0.5, so the answer to the first question is 0.5. The second question can be translated as the x value approaches -4 from the right side. The blue linear graph is located on the right side of the x is -4, so we need to follow the blue line to find the limit of the question. Yes, you find the value is -2. So we indicate the limit value of -4 from the left and from the right hand are different. So the answer to question number 3 will be D and E since the one-sided limits are different. Similarly, we can solve questions 4 through 6 where the limit approaches 0 from the left or right. Yes, the limit values for fx are both 2, so we can say the limit value of fx approaches 0 is 2 since the one-sided limits are the same at x equals 0. Questions 7 through 9 ask us about the concept of a vertical asymptote. Since the x value approaches 4 from the left and from the right, the result for fx approaches positive infinity. Then we can say that the limit of fx as x approaches positive infinity is positive infinity. Question 10 asks for the horizontal asymptote of the given function. The value for fx approaches 0 when the x approaches positive infinity. The last question asks for the limit of the oscillating graph as x approaches negative infinity. When you see the graph, the fx value keep going up and down when x approaches negative infinity. We can't determine the limit's value since the result oscillates without converging to a single value. Therefore, the answer to this question is D and E since it keeps oscillating. Let's check your understanding with the following question. The first 3 questions ask about the concept of a vertical asymptote as the x value approaches 1 from the left and from the right through the rational function. The answer to the first question is negative infinity, the second is positive infinity, and the third is D and E. Question 4 shows the indeterminate form, which was explained in the previous lesson. If you are not familiar with the indeterminate form, I recommend watching the previous video, which explains the derivative in 10 minutes. When x approaches 2, the function becomes 0 over 0, which is the indeterminate form. We need to avoid this as an indeterminate form does not yield a definite value. After factoring and canceling out the common factor, we can avoid the indeterminate form and calculate the limit as 4. Questions 5 through 7 need to calculate the limit using the given piecewise function. Question 5 asks the limit value when x approaches 1 from the left side. Therefore, we need to use the function fx equals x plus 1, so the limit will be 2. The following question asks for the limit when x approaches 1 from the right side, which is the function 3x squared minus 1, so the answer will be 2. The limit values from the left and from the right are the same. We can say the limit for fx is 2 when x approaches 1. Using the next 3 questions, let's check your understanding of horizontal asymptotes using the limit for rational functions. The first function is a rational function with the degree of the numerator less than that of the denominator. The numerator has degree 0 and the denominator has degree 1 since the exponent of x is 1. Then the limit will be 0 since the x value approaches infinity when the numerator is constant. The degree of the numerator and denominator in the second question is 1. Then they can finally calculate the coefficient for the x value as the answer, showing the process. The third question shows that the limit is infinity when the degree of the numerator is greater than that of the denominator, since the numerator has 2 x's, whereas the denominator has a constant. The numerator approaches infinity, but the denominator is constant. Therefore, the answer will be infinity. Based on the previous example, we can easily determine the horizontal asymptote using the following tips. In summary, the limit is the fundamental building block of calculus and describes how a variable approaches a given value. We can translate this to mathematical notation f approaches as shown by the symbol. Some functions' limits do not exist when the left and right-hand limit values differ. Limits clearly explain the vertical and horizontal asymptotes of rational functions. If you find this video helpful, please subscribe to my channel. I also wrote a crash course book for students beginning calculus. This book is Calculus Made Easy. You can order on Amazon.